there is hardly any other technique that is non-invasive, such as NMR itself, and gives you insights into structural information on crystalline as well as amorphous materials. And a lot of materials that are inside batteries, they are actually amorphous, which means if you apply other techniques like X-ray diffraction, you just do not get the information that you are able to sort of source from NMR spectroscopy. And you are sensitive to any type of different chemical species inside the material. And by chemical species, I mean, short-living phases, I mean, metastable phases even. And this is, of course, a very powerful technique to learn something about the chemical processes that are happening while you charge or discharge, for example, your battery material. And from that, you can conclude in some sense while a battery, for example, is failing, or while is it working so beautifully. And this then can be translated into further research, into further optimization of existing technologies of your battery, but also to learn something about how to apply new materials in the best and most efficient sense. There is definitely a lot of room where you can apply liquid state NMR when it comes to battery materials. So you can apply liquid state NMR and you can investigate the electrolyte itself, which is done by many people and is a very powerful technique to learn about the quality and the purity of the electrolyte, its performance in simple electrochemical experiments. So there you can apply liquid state NMR for sure. However, if you then look into a battery as a device, you always have solid and liquid components, or you have only solid components if we talk about all solid state batteries, for example. But let's picture like a liquid and solid state battery. So we have a liquid electrolyte and we have two solid electrode materials. So we have the interfaces between the liquid and the solid, where a lot of things are happening actually that are very crucial for the performance of a battery. And the technique of solid state NMR is then sensitive to all of these processes happening. It can actually sort of help us to visualize what is going on with the interfaces. There are things called the solid electrolyte interface and other things that are happening when the electrolyte is breaking down, or when we have short circuiting of the cell and other things, where solid state NMR can help us to learn something about all the materials and all the processes happening. Because if we do a solid state NMR experiment with a solid state NMR, let's say, equipment, we still measure the liquid components. So we see both basically. We get the full package. We get the electrolyte signals, we get the solid material signals, and we get the signals of species that are forming in between. And this is, of course, a very, very powerful technique then by intrinsically.